I'm also the technical lead for the Great Lakes and Ohio River Division Regional Energy Sustainability and Lifecycle Cost Center of Expertise. I write a acronym on my some of my slides in the past that people ask if that was a joke. That's a mouthful, I'll tell you. So today we're going to talk about Eco-Charrettes. Basically, we're going to discuss, or I'm going to tell you about what's the general idea behind these. I'm going to take you through a little bit about what we've done in design phase with respect to these, and then backtrack into what we think we might try to do for planning charrettes. There's not been a process developed yet for the planning charrettes. That's in the works now, and I'll discuss that in a little bit. So there's been several names used to describe these charrettes. Sometimes they're called Eco-Charrettes, sometimes sustainability charrettes, sometimes energy charrettes. They all really mean the same thing. The goal is to optimize energy conservation and sustainability while balancing the needs of the customer, operation and maintenance, aesthetics, cost, anti-terrorism. So we're always trying to balance all of our use our resources and use them in a responsible manner, so that we achieve all our goals. Not, and in this case, the goal is not completely maximum energy and sustainability, but we also are wanting to consider balancing against all the other factors. So there's a picture there that demonstrates that, we're looking for a sustainable, cost-effective, functional project. We have to consider, can we help the installation meet their master planning goals? Can we help the customer, the user, get some of their preferences? We have to consider ATFP, aesthetics. In addition to energy and sustainability, the focus of the Eco-Charrette, though, or this aspect of the charrette, is to make sure we're doing the best we can to achieve that optimization of energy and sustainability, not just pay lip service to it, say, yeah, that's important to us, but merely check a box and move on. What we want to do is make sure we're doing the best we can in that area. We also want to get buy-in from our stakeholders, something that what we want to do is make sure there are no surprises. So if we have our stakeholders involved in this process, we're taking them through, we're showing them all the information that helps people make decisions, maintenance impacts, cost impacts, energy consumption, utility costs, so that they can make an informed decision about what to do. So the whole team, including master planners, base maintenance, the design team, users, and everybody get to play a role in basically determining what the performance of the building is going to be. So the performance of the building is not just limited to DOR. It's completely his responsibility. No, in fact, it's the entire project delivery team's responsibility to ensure that whatever performance we get to, that's the whole team's responsibility. We're also trying to educate the customer with respect to where can they reduce energy, where can they when they do replacement or renovation projects, or they want to upgrade things, where is that energy being used in their buildings, how to plug in process loads play a part. So there's a lot of aspects to this charrette. We're trying to find synergistic solutions, so we're all working together and trying to find ways to, instead of having conflicts between different aspects of design, can we find ways to make things work together, and so forth. So there's a little quote there from the GBCI Lead Green Associate Review Manual. 70% of the decisions associated with environmental impacts are made during the first 10% of design process. That's going to be true in design phase as well as planning phase. We make decisions, especially with respect to budget, that are going to impact the decisions we make that have environmental impacts. So how do we apply it in the design phase? We have the same general project goals. We're trying to optimize energy efficiency and sustainability, still get buy-in from stakeholders. Now we have a budget that's established. We have a project amount. And what we're trying to do is get the maximum value we can out of that project amount. We're also looking for to educate the customer. It takes intense research and analyses. We're diverting focus from lead point, the hunt for lead points. We're building stakeholder buy-in. We're making sure the whole team is owning the performance of this building, and so forth. So if you think about customer education, again, we're looking at through demonstrating, doing energy modeling and demonstrating the results. We're showing where the energy is going in their buildings, so they better understand how to manage their buildings. We can discuss how the facility operation impacts energy use. So if they're a 24-hour operation, what's that going to do? What about when people don't turn off their lights? What if people are plugging in their own little space heaters all over the place? We can have those kinds of discussions. Plug and process load impacts. You can show the percent of energy in the building that comes from plug and process loads. So how they make decisions on purchasing equipment could have an impact on what the energy use of the building is. We're showing them, maybe think of things like watt stoppers, like occupancy sensors in the cubicles that sense whether somebody's not sitting there anymore and shuts off equipment, things that the customer can influence. And we can show how their particular requirements and preferences might impact the sustainability of the project. Lead focus, I don't know how many people complain about the hunt for lead points. I know my design teams here at the Louisville district, they kind of feel lead's a joke sometimes because, well, they're hunting for points. Hey, let's throw some parking signs in. We know the base is going to take those out anyway, but we're going to put them in the meantime just so we can get some points. Check that box. We're going to put some wood cabinets in just so that we can make them certified wood and get a point. We're going to pay to duplicate Corps of Engineers' existing practices, the quality management practices, with enhanced commissioning. So we're paying a whopping fee for something that we already do mostly anyway. So we're just checking the boxes, and we're not really focusing on what's important, I think, sometimes, when we're just focused on lead checklists. So what do we need to do? Well, to get the information you need to make good decisions, you got to do a lot of research and you got to do some analyses. You got to look at the climate and weather. You got to look at what renewables are suitable for the area. What are regional issues? Do they have water problems? For instance, case studies. What's been used in the area? What's been used on the installation before that has worked in the past? If you can find good success stories, that sometimes is a good way to get the customer to buy into some things they may not be sure they want to have on their project. Ground source heat pump system might be an issue. Maybe they're not real sure how to maintain it or handle it, but if you could show another base handles it fine, then maybe they're more willing to take it. You're looking at solar path, wind vectors. How is the building? Can we shade areas of the building? We need to use renewable energy calculators to screen those. Energy modeling, lots of energy modeling. Hydraulic analyses, cost estimate, life cycle cost analysis. So we put together a pretty intense data intensive package so that everybody on the team is aware of, has the information needed to make the decisions they need to make. One thing I've put on here is we're considering possibly integrating this with the value engineering efforts. So we've been talking somewhat with the VE officer on this, not as much as I'd like so far. We've just been sidetracked a lot, but there's a lot of this that duplicates the VE activities, and what we would like to do is not duplicate effort and find a way to make what we're doing with this count in the VE effort. So what I'm going to do now is show you, this is the Fort Sheridan Army Reserve Center Energy Charrette briefing. This is something that we did on a project for design phase. It's pre-design. We spent a number of weeks putting this product together to bring to the table at a energy charrette, they called it, to discuss what decisions we were going to make. These are design decisions we were going to make. And we had one meeting for this. We had already had a somewhat of a, later we had an actual design charrette, but we really already, for Army Reserve Centers, understood the functional requirements, programmatic requirements of these reserve centers, and we understood the site. We had a lot of information going into this, so we were able to do a lot of work up front. They basically spent a couple of days on this charrette effort, basically going through, they went through and described the process of how they put all this together. So they did a lot of analysis, they did a lot of research about the area, they thought about, here's the brainstorming activity, they had the whole team in there, the architects, mechanicals, electrical, civils. It was really an integrated process. They shut themselves in a room and they brainstormed, came up with ideas. They were able to immediately provide input on the ideas and flush some things out. They identified things that were already required by minimum standards. So this is something that we had lacked before, was, I guess, the funding and the schedule and the leadership emphasis on integrated design and making something like this happen. Actually get people in a room to work this out. I'll get to the meat of this thing. This is just showing, we did have some limitations on this project. They were with the ATFP setbacks at the time and the limited site area we had. We really couldn't do a lot with the building footprint. We couldn't really reorient the building much. We kind of had to work with what we had. Basically, the only thing we could do is work with where we were putting spaces to try to make sure that we were taking advantage of where daylight opportunities were, and are we getting the solar loading on the right side of the building, and so forth. So that was really the effort. I think they just did these models here with the shading and so forth in this particular case just to have pretty pictures for the show, to be honest. Here's some pictures. By doing the energy model, you understand where your energy is being used in the facility for your baseline facility. This is actually with two different kinds of baselines. This is a baseline with using gas heat as a fuel, and this is with electric as a fuel. So that actually changes your energy cost percentages. But you can see lighting is the bigger, when you comparing to a gas baseline, which is what they had. They used natural gas, and you typically would use natural gas up in this area because it was much cheaper than electric. So you're looking at reducing the area lighting is a major component. Ventilation fans, space heating, space cooling, all about equal. So, but look, just miscellaneous equipment plug and process loads are 13%. That's almost as high as several of these other components. They went through, they analyzed various, actually, they got a little in the weeds, envelope color, the different envelope components, and what they did was they would show a cost for these things, how much the energy, comparative energy consumptions and the costs, and they would calculate a life cycle cost. So all this data was presented to the customers so it helped them make a decision on what we were going to do. This is a nice little graphic that shows how the interactions of various elements of the building can impact something like reduced cooling. What are all the things that can impact cooling? So this is where we talk about synergistic measures. There's all these things in red that show up here right after reduced cooling impact the cooling energy of the building. Each of those has elements of the building that impact those, and so on. So decisions made by the architect, the electrical, all have some major impact on cooling energy of the building. They went through different features: energy recovery, ventilators, different systems, variable air volume, 4-pipe fan coil systems with a dedicated outdoor air system, They even looked at thermal energy storage, ground source heat pumps. That one actually didn't pay back in this case. They almost decided to do this anyway, but it was so expensive in the PA, the project amount was so small that they ended up not doing this. We looked at, let's see, variable refrigerant volume systems. This one actually did have a very favorable payback, but the installation, or the Reserve Support Command, who's the equivalent of DPW for Army installations, weren't thrilled with this. This system has some issues with controls, integration, and a few other things. But even though it had very favorable payback and was a very big energy saver, they decided not to go with this one. And the good thing about what this demonstrates is the team, again, owning the performance of this building. The team made the decision not to pursue this, knowing that it was going to have an impact to the bottom line of our impact energy percentages, our lead percentages, and the utility cost of the building. So, we made the opposite decision on, let's see if I can find it. We go into renewable energies. I'll get there when I get there. Renewable energies, solar hot water heating. We looked at, in that case, no, it didn't pay back if you had a gas baseline, which is what we were going to have. If we had an electric baseline, yeah, it was going to pay back just because the electric rates were so high. So if you were in this, at this base building to building, and if, for instance, they had no natural gas, or you're going to have to run a gas line 2 miles, you might put in a solar hot water heating system because that would have been life cycle cost effective. Now they also looked at a transpired solar wall, which I couldn't find in this, and they found it was not cost effective. In fact, it had a 100-year payback, but because it was a passive feature, and because there's not much maintenance associated with it, the RSC and ARMD, ARMD is kind of like the Axum equivalent for Army Reserve. They liked that. They wanted to have the transpired solar walls. So it's not all about life cycle cost and the energy costs. You know, sometimes it's just what is the smart thing for them? What do they feel like they should be doing? So that's the kind of data we're trying to show on these Eco-Charrettes for a design phase, so that everybody is armed with the information they need to make decisions. This is just the HVAC systems. On this project, they didn't do this. We'd like to do it on future projects, but they didn't roll up all the recommended features into one single, I guess, % energy reduction. This one's showing just for various HVAC systems what the different percentages we were going to get out of it. So again, we were kind of pointing toward the variable refrigerant volume as being a high payback system. We ended up falling back to a variable air volume with ERV, and that was, look at that difference, 17.27% compared to 49.87%, and that's just with the HVAC system. So this building could have been an energy sipping LEED Gold Platinum building, but we kind of passed that up in this case, and that's okay. That's just what the customer needed. So that's in design application. Moving on, I call this site planning. I don't know if anybody knows Donna Thompson. She corrected me. Site planning is really about master planning. I told her, to me, site planning was anything that we planned for that particular site. Whatever, it's just terminology. Really what I mean here is the 1391 planning charrette. When we developed the document that we're going to use to basically budget the building and request funds from Commerce to build a project. It has the same project goals. We're trying to optimize the energy and sustainability of the building, but balance against other issues. We are concentrating on establishing the appropriate budget. We also want to help meet the master planning and installation sustainability goals. Customer education, again, make it so they understand what impacts their requirements and preferences have on the project. Look at the sustainability goals, installation sustainability goals. Like by 2030, we got to get to net zero. They have to have reduced energy intensity by a different amount per square foot every so many years. They have to have so much renewable energy, greenhouse gas reduction, water consumption reduction, waste diversion. what are the master planning goals? Well, they got to handle stormwater, low impact development. They got to worry about landscaping. Can they make their facilities into a transit-oriented community? They have to worry about infrastructure, anti-terrorism. There's so many competing issues, but we got to consider all these and still try to meet our energy and sustainability goals. And concept research and analysis. You do a lot of the same, what we're proposing is we do a lot of the same kinds of analyses and research, if at a much reduced detail and a lot of less items we're checking out. I'll get to that in a little bit. Here's a diagram that Don Thompson provided me, I think, yesterday. This is what we do now currently in planning charrettes for 1391 development. We have a pre-charrette phase. Army makes a decision, hey, we got a need. There's requirement analysis. INCOM says yes or no. Then, really that's when I think our team gets engaged. We gather information from the users from the site. We're looking at, hey, let's get a hold of the master plan, the integrated sustainability plan, the manning documents. Tell us what, we want to get information about the equipment the user has, vehicles. We need site information, utility base maps, etc. Then we move into the actual charrette workshop. So that could be a couple of meetings. That could be 1 week-long meeting. It just depends on the situation. One size does not fit all. But in that phase, there's a lot of collaborative sessions with master planning, the users. We talk to environmental representatives, utility representatives, energy managers, physical security people, anti-terrorism people, IT people. Really, we're fleshing out, hey, what are all the requirements for the facility? What kind of input can they give us on where are we going to grab our utilities? What kind of, can we reduce setbacks if we do something like build a fence around this thing? We get a lot of input out of these people. I'll get into that more in a minute. It moves on to post-charrette after they've basically come up with, through this collaborative effort, a concept site plan, a bubble diagram, or a sketch of the facility itself. They filled out a lead checklist. They've done estimated some preliminary costs. They do an out brief and they move on to post-charrette. So things are more finalized. We get people leave the meeting, they go do some tasks. The anti-terrorism guy does a risk assessment and a threat analysis. Somebody's checking on the NEPA status. The cost estimator is finalizing his estimates. Then we move forward to processing and reviewing the 1391. That's what happens now. Here's a typical, well, I shouldn't say typical. None of these are necessarily typical. This is actually an agenda from a planning charrette that's going to happen in a few weeks in Detroit. I kind of boiled it down into the various tasks. The first day they're really visiting the site, visiting some existing facilities in the first couple of days actually, meeting with the users, meeting with the master planning facility people, and getting a good idea of the functional relationships, programmatic requirements, equipment needs, and so forth of the users, so that they can start developing a sketch of what the concept facility is going to look like. Make sure they get everything, they can get everything they need into the square footage allotted. They also, on the side here, the civil engineer is working on a lid worksheet, trying to figure out where the parking is going to go and so forth. And then through the rest of this week, they meet with the various stakeholders on the project and get input from all of them. And meanwhile, even though they're having these breakout sessions, I believe the architect and civil are continuously tweaking things that are going on in with the concepts design, or in quotation designs, concept sketches. And at the end, they give an outbrief. Here's what we've come up with after we've received all the input we need on this process. Here's kind of our where we ended up with. So, who are the people there? Well, everybody that can make a decision affecting the project shows up at that meeting at one time or another. So from the Corps of Engineers, we normally have a planner. We might have a project manager. We have a cost engineer, an architect. Sometimes the planner might be able to fulfill that function if they have that competency, I suppose. The civil engineer, electrical engineer. Now here in Louisville, they almost never take a mechanical engineer. The electrical engineer, we give them a rule of thumb calculator, and the electrical engineer figures out the heating and cooling loads for the building, which is fine for what's going on now. The using agency shows up with their whoever's using the facility. They might have some technical points of contact, people that understand how the facility is going to be used and their needs. And the installation, of course, have their master planner, environmental utilities, NEC, energy manager. All these people ought to be at the meeting at one time or another. And hopefully the master planner is there basically the whole time to help coordinate everything. And they kind of seem to be the driving force behind how the facility is going to go together, I believe. Let's see. So what is different about an Eco-Charrette from what is done normally? We don't know yet. We don't have a process down yet. But remember what the goals are. The goals are to optimize the energy efficiency and sustainability of the building, get buy-in from the stakeholders, and we do want to balance them with all these other issues that are already handled through the process. What those goals boil down to is reduce energy consumption, we need renewable energies, reduce water consumption, and we need to handle low-impact development requirements. We reduce energy because there's finite resources. It's a smart thing to do. We're not going to have, we don't have infinite sources of oil. We don't have infinite sources of coal. We need to reduce the amount of dependence we have on those emissions. So we're polluting the atmosphere. We're creating greenhouse gases, and the Arctic is melting. Utility infrastructure. We're dependent. Utilities have to beef up their utility infrastructure as load is continuously added to the infrastructure. So by reducing the energy we use, the utilities don't have to constantly upgrade their systems, which takes more resources, materials, more energy, more emissions, and so forth. We reduce our O&M costs, our operating costs. We reduce our dependence on the infrastructure, our energy infrastructure, and that's for energy security. And then we're making net zero more affordable. We reduce our consumption, then we have to buy less renewable energy, or alternative energy sources. Renewable energy is important, obviously, for energy security. Not to mention, if you can get it life cycle cost effectively, it's also a smart thing to do. It helps you with your O&M costs. We reduce water consumption, again, finite resource of fresh water. Again, same as energy, we have the utility infrastructure that has to keep growing as we keep adding water demand to the utility. O&M costs are in there also, and if we reduce water consumption, we're less vulnerable to an issue with that utility infrastructure. Low impact development. We need to reduce the impacts to the environment from stormwater runoff. So look at a parking lot. All the oil and nasty stuff that might collect there. You can look around and see litter all over the place. That stuff ends up in our stream channels, cause erosion and sedimentation in the stream channels. So we clog them up. We have sedimentation in there. The light's not as good as it was diffusing through the water. There's not as much food. The habitat's getting impacted. And the most important reason, I guess, for me would be because we're required to do it by federal mandate. So who's different about the people that show up to this thing? Well, not much. All the same people need to be there anyway, because we still need all their input on all the various issues and perspectives on what we're doing with this project. Maybe you add an energy modeler, and that could be the mechanical engineer or architect if they're competent to do that. But bring somebody with you that can run a very quick energy model when necessary, or understands various, or has various calculators they can use to do some quick estimates. So, as we saw earlier, the information that the customer is getting to make decisions is what's really important in making sure they understand, I guess, the implications of their decisions with respect to energy and sustainability. What's the cost of what I'm doing, of our alternatives? How much energy am I going to save? Am I going to save operating funds? Is it going to increase my maintenance? Is it going to total cost of ownership? Is it going to be higher or lower? They need all this information to make decisions. So the extra work that's being done is a little bit of energy modeling. We're looking at renewable energy, quick calculations, life cycle cost analysis, stormwater calculations, and cost estimating alternatives. And instead of just waiting until the end and we got some solution and doing a cost estimate, we need to be estimating various solutions as we go through the process. There's some pictures there. The bottom picture is a shot of what VLCC5 looks like. That's for life cycle cost analysis. Up there in the top right, I just found out a few days ago that there's already a quick calculator for low impact development for stormwater runoff, which is great. Maybe it needs a little bit of refinement, but that's a great start. They already got something that they've been working with. So they're breaking down the activities a little bit. We're thinking about, should we be doing energy modeling to look at massing and orientation of the building and where we're putting spaces, making sure we get enough daylight into the occupied areas, while also looking at the functional requirements and our constraints and what impacts to the site. If our footprint grows, what's that going to do to the site? Why do we do all this? Well, I was talking to a cost engineer that does this. He says, hey, it doesn't matter what the building looks like. My cost estimate for the building doesn't really change. So, okay. And what are we going to do? Are we doing all this and we're going to preserve the design? Are we going to develop basically a floor plan that's going to live through the life cycle of the project? Or do we continue to basically throw that away when we get to 3086 or design phase and let the designer start over fresh? I don't know yet. Are we doing this just to make sure that see how the footprint affects low impact development? I don't know. So this is something we still need to kick around and consider. Is there some value to doing this energy modeling of the facility itself during the planning phase? And I'll get to, we have a team working on that and noodling that over, and I'll get to that in a minute also. We would look at high cost measures, energy conservation measures, and actually water conservation measures. Why high cost? Well, because there's a lot of error in these calculations. So the cost estimates are concept level estimates. They're very quick. There's a lot of error there. There's error in the energy calculations and the water savings calculations. So if there's a lot of error, the higher cost kind of offsets the fact that you got some error. If you're trying to get down in the weeds to small little energy conservation measures, the results are going to be nonsensical almost completely. So there's a threshold. We don't know where that is yet. A threshold where the higher the cost, the more this pays off to do this analysis early on to make sure we got the budget for it. But below a certain threshold, it's going to be within the error of the calculation. So it doesn't make much sense at this point. And then again, remember, the goal is to have a budget that encompasses these things. So what's a high cost measure? What about having a well field for ground source heat pump system? It's a common complaint we get. Hey, we could save a ton of energy if we have a ground source heat pump system, but we don't have $500,000 for a well field. That's something we ought to be looking at in planning stage to make sure we've got it budgeted if it's going to be feasible. When you look at renewables, look at doing, why do we do renewables? Well, some of them are high cost. And the other thing is they're easy to screen. There's not a lot of down in the weeds design work. Basically, if you save energy, if you generate energy, that's all you're calculating. How much energy can I generate? How much area do I have to locate these things, and is it life cycle cost effective? So easy thing to check and budget for if it's something we ought to do. We need to look at centralized measures. Do we have the opportunity to share, group buildings together and share energy from the district energy system, or share renewables, share a PV array, share a ground source heat pump well field, because it's kind of like the Walmart approach. They buy in bulk and it's cheaper. But yeah, the scale of it, the larger it gets, the more cost effective it tends to be. I already talked about water a little bit. Low impact development. We can do some quick stormwater calculations. I showed you a tool they're already using for that. We need to consider the maintenance considerations. You know, I've heard this. My soldiers are going to just mow down all the plants anyway. They have no idea what to avoid, what not to avoid. You know, there's a bunch of plants in here, and I don't know how to take care of them. We've got to consider those kinds of things. And just to backtrack a little bit, we need to consider that for our water and energy conservation measures also. What are the maintenance impacts for our installations for all these features we're putting in? So at the end of the day, you might say, hey, this is life cycle cost effective, pays back in 5 years. And the guy at the base that maintains it says, well, it's going to fail within a year and never work again. So that's something you need to consider. What are some, moving forward, we need to look at tools that are available to do these things. What are the various energy modeling softwares? Are there quick calculators we can use? Life cycle cost analysis. Well, here's a few examples. The quick calculators, there's a step calculator Fort Worth has been working on that does some pretty quick analyses of various renewable energies. And right now, I think they're working on developing something that looks at windows. So a pretty quick tool, maybe something that'd be easier for people to use than doing a full-blown energy analyses and so forth. But that's just one tool that might be in the toolbox. Like I said, there's a lid worksheet. BLCC5 is a pretty quick way to do life cycle cost analysis. If you go to DOE's website, I got a link or a path there. They have all kinds of, they got a huge list of available resources, software that you can use for analyzing various sustainability energy related features. So what do we need to think about as we look at adopting or acquiring tools or developing tools? We need to look at accuracy. How accurate can we get with the minimum of inputs? We're talking about a very short time in the field to work on these things. We got to have something that works fairly quickly and somehow is accurate. Now those are in direct conflict with each other, but that's something we need to think about and try to find. Training, no matter what we do, no matter how easy it is, you got to have training on the tools that you're using, and experience. Once you're training, you need to have plenty of experience using the thing. So people need to, whoever's going to be doing these things, need to be out in the field doing them quite often, so they get a good handle on how these things work. You know, crap in, crap out on these energy models. So you need to understand what inputs you put in affect how they affect the output. What inputs matter and what don't. Cost of the software. You know, what's our cost per seat for license? You know, what is it going to cost us to develop software or maybe refine? What if we want to refine the step calculator or refine the lid worksheet? What's it going to cost us to do that? We need to think about the tools we have. Do we need to add features? Do we need to refine them? Look at the lid worksheet. The other day I heard that, you know, at Fort Campbell we have a lot of clay. So when you enter clay soil conditions into this worksheet, it acts like it's completely hard stand. So that's something that needs to be refined in that calculator. So these homemade calculators need constant maintenance. And maybe look at some of these, whether we acquire software or develop it, you know, regional defaults. Can in the Southwest, do I always have settings that are the same, and it doesn't really matter? Do I need to change them? It might make things easier as you get in the field and cleaner. Integration. So we have this team, the planning phase team, these regional centers, energy sustainability and life cycle analysis centers. There's a number of the centers that have grouped together into this planning phase team. We're trying to figure out how can we increase sustainability and energy considerations in the 1391 planning charrettes. The team is made up of various districts, USACE headquarters, HNC, all these people involved. I have Donna Thompson. She does a lot of the planning, and she works on a lot of these 1391 charrettes. She's really helpful. I think right now we're just kind of getting a handle on what's done now, and so we can see where to move forward and where we might be able to improve some things. If you want to know more about the centers, I got a link here on the page. You can follow that to the homepage for these centers. Every district has or division has a responsibility in different renewable energy technologies or different processes or and so forth. So what are our challenges and considerations? Well, obviously, we got an existing process. It seems to work very well. They already consider sustainability to some extent. So, you know, what we're trying to take something and layer it over an existing process, and obviously that's always going to be rife with conflict until we figure out a compromise. How are we going to get all this to work? So some of the challenges or considerations, we need to consider the impacts to master plans, and from master plans onto these projects, and the connection between those we need to work out. And do we need to backtrack all the way into master planning and make sure we're considering sustainability sufficiently in master planning? We don't know yet. You know, we need to think about the fact that analyses are high, prone to error at concept level. So, you know, it's a comparative analysis, and you got to take all of this with a grain of salt. Ensure that whatever analyses we do, they have some benefit that outweigh the cost and the schedule impacts to the planning charrette process. We need to overcome high cost red flags. So, you know, I hear that when HNC or MCOM or somebody's reviewing these things, if we trip some threshold, monetary threshold, they kick them back down to this. Maybe we need better documentation to back up those things. Not sure how to get through all that, but you know, first let's figure out what we're going to do and figure out what things we need on the project, and then we'll deal with how do we approach getting the funding we need for these things. Inability to predict changes in technology. So no technologies. We're doing a planning document here that the facility may not be built for 5 more years, or it may not even be in design within the next 5 years. So we don't know what's going to come along in that 5 years. There might be something that much cheaper, but can get us a lot much easier maintenance, but give us a lot of energy savings. We're going to miss out on some of those considerations when we're doing the planning. And obviously, we have an inability to accurately predict energy consumption. We're not really going to be sure how much energy. So no matter if we throw in ground source heat pumps, we throw in renewable energy and so forth, we still couldn't tell you what an EPAC percentage is going to be. If somebody gives you that number, it's a bunch of baloney. So there's still a lot of uncertainty in all this. So summary, Eco-Charrette goals: optimize energy conservation, sustainability, and balance other factors. We need buy-in from the stakeholders. We're educating the customer on how requirements and preferences impact sustainability and how their operations impact sustainability. We can apply it to design and planning phases. We haven't worked out how to do it in planning phase, but I think it's if you're going to budget something, you need to have a way to decide what it is you're going to budget, and we got to have some data to back that up. The information, decisions are made based on information. We got to have sufficient data. We can't just shut our eyes and throw a dart and hope it hits the mark. We need to do some studies, analyses to make sure that we have the data we need to make appropriate decisions. And integration, we're still working on how to implement this into the planning process. And we're trying to do it in a way that minimizes the cost and schedule impacts to charrettes. We're trying to identify the tasks that add value, and we need to get figure out what are the right tools to use. That pretty picture, I know it's hard to believe, but that handsome man is me. They forced me to smile. You can tell it's a fake smile, but there's my contact info if you need it. And hey, we just got this, came out from headquarters today. This is the sustainability business card, so just in time for me to add it to the slideshow here. And that wraps it up. I guess.
Thank you, Brandon. We really appreciate your time in doing the presentation. Right now, I don't have any questions, but if anybody wants to write in a question to the Q&A box that's located in the center left of your screen, Did you want to talk at all about the upcoming ECB and its release?
Sure. Well, I guess we've been tasked to develop an ECB that identifies the tasks we should be doing during the Eco-Charrette, during planning, what considerations there would be, what do you think about when you're in the planning phase, and you know, what outputs are we looking for from those activities? For instance, energy modeling. What level of energy modeling would you expect? What are you thinking about while you're tweaking, looking at all your alternatives that you're checking out, and what kind of output do we expect from that? What kinds of systems are we looking at doing quick calculations on energy reductions, and what do we do life cycle cost analyses on, and how do we handle lead? That's I guess due by the end of the fiscal year, correct?
We do have another question. Oh, go ahead. It's all right.
We have a whole team working. Okay.
All right, the next question is the statistic that said the 70% of environmental design decisions are made in the first 10% of design. Can you talk a little bit about where that came from?
That came from the, basically I stole that from another slideshow, but they were quoting the Green Associate exam book, the Lead Green Associate exam book. I'm not sure where they got that statistic, but I've seen charts that kind of show you, they'll show on the long axis, the horizontal axis, the time of the project from pre-design all the way through construction, and then they'll show effort on the vertical axis, and they'll talk about, basically the idea is to show you where the greatest impact is. I'm sorry, the vertical axis is impact, but the idea is to show you where decisions make the greatest impact. Decisions always make the greatest impact early on. If you wait until construction to make a design change, you're in trouble. You have a lot of time and cost growth associated with that. You got a contractor already, he's going to gouge you on the modification, and then you got a host of other interconnected issues you got to deal with. If you make that decision during design, obviously you got time to work out all the interconnecting issues, make something, and you got time to consider what can I do to add the best value to the project, maybe not the cheapest thing. In construction, you're usually looking for the cheapest thing. If you look at pre-design, we make decisions before we even start that will affect design later. So let's say we're in design phase. Let's look at HVAC design. I've already done load analysis. I already know what my cooling and heating loads are for a building. Once they've established what the building envelope is going to be and where the spaces are and so forth, and I move forward with an HVAC design. If somebody makes a building envelope change and says, you know what, I'm going to make this thing very energy efficient envelope all of a sudden. Well, now there's a lot of lost effort and time going back and redoing all the calculations and so forth to make that happen. And you run a risk of some quality control issues there, because you maybe forgot to coordinate a few things in the design, and then that makes a time and cost growth effort later. Think about it with planning. When design phase, we're already stuck with a budget. So it doesn't matter, whatever the 1391 team did, it doesn't, by the time we get to design, we have a fixed number that's a budget. So let's say we wanted to put ground source heat pumps into the project. It cost us, $500,000 to build the well field or something. Well, we don't have that. We don't have that budget. It might pay back in 20 years. It may save gobs and gobs of energy. It's a smart thing to do. But we just don't have the money for it. So that's a good illustration of, hey, if during planning stage we had evaluated the use of ground source heat pumps and budgeted appropriate for it, we would have had the funding available. So I guess more in the way of examples of things that could happen.
I think that's a good response. We have two other questions.
I don't know about the figure itself.
One, Russell Pearson asks, In design build projects, would any of this be considered over?
I'm guessing that the overscoping is are we talking about doing like an Eco-Charrette during RFP preparation, or asking the contractor to do some level of this after award? I guess I can speak to both. You know, in RFP preparation, we have done that here in the Louisville district one time, just as a test, trying to figure out what can we do that's useful in RFP prep, knowing that we're not doing the design. And so we do a lot of concept level analysis, similar to what you might do in the planning phase, not knowing what's going to be actually designed. We basically make up a dummy building, try to test different systems out, figure out how much energy they use, and then we figure the maintenance data and do life cycle costs. Now, all of that is very rough analysis, but it's a comparative analysis. And what we did is basically stick that in an appendix and tell the contractor, you know, we did all this analysis, and here's how the systems rank out. And then they can make their proposal accordingly. They can ignore it completely and do whatever they want. They could give us a system that's on there. The other thing it does is the evaluators, the source selection board, can look at that, and they have a tool by which to compare various contractors' systems. So if you got a best value type selection, they can say, hey, you know, this system this contractor's proposing, not such a great system for us, lots of maintenance or whatever. But if I look at this chart Brandon gave us, it says, hey, this isn't such a good system. But maybe this other contractor B over here, he says, look, this is a very energy sipping system. The maintenance is a lot less than for the other systems. I think we like this system. So you can make some kind of determination there. After award, a lot of this goes out the window. After award, we don't care about life cycle cost anymore, mostly. All we care about is operation and maintenance savings. So after award, what we're doing is, all we'd be doing is asking the contractor, hey, can we have some kind of analyses and so forth, in a collaborative effort to see if we can come to some consensus of the best system you're willing to give us, given the price that you have a fixed price contract that's an energy sipper. What we've been recommending is, if you're going to do this, do it during RFP preparation, and give yourself some means by which to evaluate proposals. I think that's probably the most bang for your buck on that. The other thing that's been kicked around is, do we mandate that they use the systems that we decide are what they should use? And that there's two sides to that, obviously. Well, we've done all this work. We feel we're pretty strongly that we know what the right answer is for systems and so forth. If we do that, we tell the contractor to use that. We need to take upon ourselves the responsibility of what the end performance is going to be for the building. A lot of people aren't comfortable with that. They want the DOR to be responsible for that. And in that case,
okay, we have two more quick questions. One, are there any resources to support having an Eco-Charrette? Because most districts don't have the knowledge base that you're speaking of.
Okay. Well, no, nothing. I guess specific. There's scattered tools we can use. Like I pointed out, there's energy modeling tools, software, quick calculators. NREL, I put it on our Center of Expertise website. NREL has published a book about energy modeling for charrettes. Talks about how you go about doing those energy models. It's something we need to build a competency in. Now, we have competency in the core with basically energy modeling, mostly for compliance with LEED and so forth, and that's very detailed modeling. We have plenty of competency in cost estimating. We have all the pieces and parts. We have very smart engineers all over the place with PE licenses and everything. And I think it's just a matter of training people to tailor or getting the tools that we need to tailor them to something as quick-paced as a planning charrette. Getting those tools to where we can.
And I think I'll add to that. You kind of mentioned this a little bit, but we do have a CX for the charrettes, And so we do have a website, which is the same website that these recordings are posted to, that has information on it, as well as the ECB that will come out that will kind of give periphery direction. And then that ECB will later be rolled up into a larger ER that will provide kind of overall guidance. And then from there, we're looking at development of design guides. So those are kind of things that are in development, but if you have questions with your teams immediately right now and you want to know where to start or points of contacts, then I would encourage you to visit the Centers of Expertise. And then last question, this is from a mechanical engineer, a fellow. I understand the value of having a life cycle cost analysis at an early phase in the design, but what tools are available to identify the cost of those systems, capital, maintenance, etc., when the criteria for the system design is not quite identified?
Okay, good question. So on the capital costs, we you know, let me use this example of a ground source heat pump system, because that's a high dollar system that we might evaluate. Well, you use means. You look at the cost of various heat pumps and so forth, and since you're a mechanical engineer, I'll get a little more technical. You have to pick which system architecture you're going to build your cost estimate around. So there's various ways to do ground source heat pump systems, obviously, and you can decide, hey, I'm going to use the most expensive means in order to make sure I have plenty of budget for it. Where you can think, okay, however you want to approach it, you do have to go ahead and make some, I guess, design decisions as you do the analysis, realizing that you got some error in there. The well field is probably going to cost. It's going to cost whatever the well field is. You don't have a lot of scenarios with that. You just do the best you can. We had the same problem during design phase, even though we could take whatever we do and carry on. We haven't done any design yet, so we're still doing all this at an early level. You just do the best you can, and we typically use means or we call vendors, and same way the cost estimators do, basically. The other side of it is the maintenance data. There's not really a good source of maintenance data. We use means, but means is an average of everything across the country. You apply some area cost factors, but that's probably reflects a very good maintenance and preventative maintenance system. Look at your installations. I don't know about every installation. Fort Campbell, I think sometimes operates on a break fix. So you're overestimating if you use means, but at the same time, when means says replace it at 15 years, you're probably thinking more replace it 10 years. So you're going to have to use something like means. We need to think about, are there any other sources of good maintenance data we could use, and use some judgment. Use the maintenance staff at the installation you're working with and see what kind of information they can provide. I agree. That's a really
well. That's all for the questions really for right now, and we're just at time. So this was a perfect and well done presentation. You did a great job, Brandon. I really enjoyed listening to it, and thank you for being a presenter. So for everybody on the line, this is recorded. We will have the recording available on the website by the end of the week, so please be sure to visit our Sustainability and Energy website. The link is at the lower left-hand corner and also in the invitation. Next week, we're going to have a presentation by AEF on power systems, and they'll be doing a recorded demonstration. So look forward to hearing that next Tuesday at the same time, located here. Thank you.